All right, boys and girls, now we're moving on to Explore 2. And again, you have this in your textbook or in the notes that I provided. And I highlighted a few things because these are the things that I feel like are really important, okay? First of all, you're going to be getting polynomial functions written in what we call x-intercept form. Okay, so again, they're going to be polynomial functions written in, let me highlight that, sorry, an x-intercept form, okay? A couple things you should know. The way that it's written has degree n, where n is the number of variable factors. So consider these your factors. Okay, depending how many of these you have, it'll actually tell you the degree of the actual function. Okay, remember, degree just means exponent. Okay. All right, the next thing is, so I already told you it's intercept form. P of x intersects the x-axis only at its x-intercepts. Okay, so real quick, here's your grid, and it'll only intersect on the x-axis. So depending on what it looks like, here, 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 here. Those would be your x-intercepts. Okay, that was just a quick example. All right, then the other thing is it's going to have turning points, okay, between those x-intercepts. Now, if you're thinking, what are turning points? Well, remember, I was calling these waves. It goes down and then up and then down and then up. So where it changes direction, those are turning points. So see, it goes down, and then here, all of a sudden, somewhere along here, it's going to decide to go up. So here's your turning point. Then it goes up, and somewhere here, it's going to decide to go down. That's a turning point. It's going to go down. Somewhere here, it decides to go up. That's a turning point. Okay? So remember that regarding the turning points. Okay? Also, instead of crossing the x-axis at an intercept, the graph can be tangent. Okay? So here I showed you where it crosses the x-axis. It could also be tangent. What tangent means is it might do something like this. So here it crosses the x-axis. That's an x-intercept. Here it'll just touch it. Okay? It doesn't go through it. It just touches it. So this means it's tangent. Okay? It'll all make sense once we start doing an example. So the point of tangency becomes a turning point because the graph must move towards the x-axis, then away from it near the point of tangency. Basically, at this point, it becomes not only a tangent point, but it's also a turning point because that's where it must have gone up. And at that exact point, that's where it decided to go down. Okay, so that's a turning point. All right, then other things you need to know. Let me move this up. It says the y-coordinate of each turning point is a maximum or minimum. Okay, the y-coordinate. So here it went up. So this is a maximum because it's up. Down here, it went down. This is a minimum. See how it's down? Maximum, minimum. Now look at this one. This is a minimum because it's down. Maximum, minimum. Okay, and it refers to your y value. So you're looking at it only going up and down, up and down. Okay. And then what else? A maximum or minimum value is called a global or absolute if the function never takes on a value that is greater than a maximum or less than a minimum. Okay, I'll show you. It makes sense. We're going to use the word global and not absolute, okay? And I'll show you that in a minute. And then we have something called a relative maximum or relative minimum. Is a maximum or minimum in which some interval around the turning point that need not to meet but may be a global maximum or global minimum. Okay, I'm gonna show you this with using these two examples. Okay, so hold on. Okay, let's start with the first example that I give you. And it's a rough sketch, nothing perfect. Okay, just by looking at it, you could tell it's negative. Okay, how can you tell it's negative? It starts up high and it ends low, so it's negative. Okay, And you can tell this is an odd function. It goes down, up, and then down. So this probably has a degree of 3, okay? So a couple things I would point out here. This is a turning point, and this is a turning point, okay? So we have 2 turning points. This is where it changes directions. So it goes down, then up, and then goes down. Remember, in those turning points, it's where it decides to change direction, okay? So this point is considered a minimum. This point is considered a maximum. So min and maximum. Now, if you're wondering, should this be a global or a relative? These would both be considered relative, okay? So this is a relative min and a relative max, okay? And let me explain why. There's no other minimum, there's no other maximum, so there's nothing to compare it with. There's nothing to say it's bigger than the other minimum or larger than the other maximum. So because of that, we just say relative min, relative max, okay? So now let's look at this one. This one's a little bit different. This one's a positive because it's starting off high, if you look, and it ends going up, okay? So up, and then it ends up. And it's positive, and it is probably an even because it goes down, up, which is probably a degree of 4, okay? Again, this is just a random sketch and just a rough estimate. So how many turning points does this one have? 1, 2, 3. By the way, there is a correlation between the number of turning points and the degree, okay? So hopefully you do enough of these, you see the relationship. Okay, so turning points, it decided to go down, and then all of a sudden here, it decided to go up. So that's the direction it decided to turn, okay? So this is a minimum, this is a maximum, and this is a minimum. Okay, because we only have one maximum, we just call that our relative max. Okay, now we have 2 minimums, so we just have to compare our minimums. Okay, so can you tell that this one's going further down than this one? Okay, hopefully it's obvious. Well, if that's the case, then this one's considered a global minimum, and this one's considered a relative minimum. Okay? All right, and I think you have enough where we can get started now. So let's move on to an actual example. All right, boys and girls, now we're going to move on to sketching the graph of the polynomial function. Okay, so I'm going to go in very detail for the very first one, okay? Now remember, we don't need a calculator at all for this. So a couple things you need to know. This is written in intercept form, okay? So if you notice, these are factored, okay? So just think of it. These are your factors, okay? So it's in factored form. Some people call it intercept form. Some people call it factored form. They are factors, and the reason why they're called intercept form, because you can find the intercepts, okay? And that's the first thing we're going to do. So here we go. So just remember, these right here are all your factors. Okay? So in order for us to find our x-intercepts, we are going to set our factors equal to 0. Okay? So I'm going to set our first factor, which is x, equal to 0. Our second factor, x plus 2, equal to 0. And our third factor, x minus 3, equal to 0. And then you're basically going to solve for x. Now in the first one, there's nothing to solve. They already solved it for you. So that's it. And the second one, we're going to subtract 2 to both sides, and our x equals negative 2. Okay, and then that's it. The second one, we're going to add, or the third one, sorry, we're going to add 3, and you get x equals 3. And that's our third intercept. So basically, what you just solved for are your x-intercepts. Okay, and then I'm going to show you how to graph those. Okay, so then you just come over here on the graph, and on your x-axis, you plot these 3 points. So there should be a point at 0, a point at negative 2, and a point at positive 3. Okay? Now, another thing you should know, Since we have 3 factors, that tells us this has to be a degree of 3, okay? So the number of factors should equal number of degree, okay? So obviously this one has a degree of 3. So that should give you an idea of what this should look like. That means you're graphing a cubic function, okay? All right, let's move on to the next part.